Hello student, I am Dr.A.K, Professor of Chemistry. Last class I have discussed enthalpy change of the reaction. Enthalpy change, that is delta H of the reaction, that is also called heat of reaction. Today I am going to discuss standard enthalpy of formation. Standard enthalpy of formation. What is the standard enthalpy of formation? First you should know the standard enthalpy change. The standard enthalpy change for the formation of 1 mole of a compound from its elements in their most stable states of aggregation, also known as reference states, is called standard molar enthalpy of formation. Again, try to understand. This is what I told, that is definition. Now try to understand the standard enthalpy change. Standard enthalpy change for the formation of 1 mole of compound. You are talking about formation of 1 mole of compound. How it will be formed? Then from its elements. You know that compound is formed from the element. Then what type of element? What should be the condition for elements? Then from its elements in their most stable state. Elements should be in standard state, most stable state of aggregation. Aggregation means just collection. Okay. Elements in their most stable states of aggregation, that is also called reference state. Then this standard enthalpy change is called standard molar enthalpy. Because why molar enthalpy? Because you are going to make 1 mole of the compound from its elements. 1 mole. Keep in mind, not 2 mole, not 3 mole, only 1 mole. Then that's why it is called that molar enthalpy of formation. Molar enthalpy of formation. And its symbol is delta F. Delta F, a small f. F means formation. Delta F H, capital H. Delta F H. Okay. This is called enthalpy of formation. Standard enthalpy of formation. Wherever the word standard you are using, it means its temperature and pressure must be in a standard condition, a standard state. That is that temperature must be 273 plus 0, that is a 273 Kelvin, and this pressure should be 1 bar, not atmospheric pressure, 1 bar. Okay. Then here you can understand by the example also that the reference state of element, the reference state of an element is the most stable state of aggregation at 25 degrees centigrade and 1 var pressure. At 25 degree and at 1 var, that will be in a stable state. Element will be in most stable state. Okay. This you should keep in mind. The reference state of an element is its most stable state of aggregation at 25 degrees centigrade and 1 var pressure. For example, the reference state of hydrogen gas, dihydrogen, H2, that is also called dihydrogen. Then the reference state of dihydrogen is H2 gas, that is the standard state, also called reference state. And those of dioxygen, Dioxygen means oxygen gas, O2. Then for dioxygen, carbon and sulfur are O2. O2 is the standard state. Okay, oxygen gas, standard state. That is a reference state. And for carbon, Graphite, that is a standard state, graphite, in the form of graphite. And for sulfur, rhombic sulfur, S rhombic. 1 marks question for medical and engineering. Okay, 1 marks question for the reference state or standard state. Temperature, I told you 25 degrees centigrade, and at 1 hour these elements will be in a most stable state. And H2 is a reference, H2 gas is a reference, oxygen gas is a reference state, carbon graphite is a standard state, means reference state, and sulfur rhombic. Sulfur exists in so many forms, but sulfur rhombic is considered as a reference state or standard state. Okay. Now I am giving some example of enthalpy of formation. Enthalpy of formation, I told you, also called heat of formation. For the term enthalpy, heat, in the previously actually heat was used. Heat for the enthalpy. Enthalpy is a new term. Okay, heat of formation. Earlier it was called heat of formation. Now it is called enthalpy of formation. And already I told you that H means enthalpy. H is equal to E plus W. Correct? Internal energy plus work done. Don't forget. Then now example of enthalpy of formation, I am telling you that H2 plus half O2. H2 plus half O2. H2 is in gas plus half O2. Oxygen is also gas. Both are in gaseous form. Then it will form what? H2 plus half O2. What will it form? It will form H2O, liquid L. Here you must write in bracket physical state of the element, okay, or molecule. Then here H2 is gas. Then in bracket you write a small g. And oxygen half O2 plus half O2. Then oxygen gas. Then again in bracket you write a small g. And it is forming liquid. Product is liquid. Then after arrow sign you write H2O. And in bracket a small l you write liquid, because water exists, liquid water. L means liquid water. Okay. H2O may be solid, H2O may be liquid, H2O may be vapor also. Hence you must write what H2O you are talking about. Okay. Then here L. Then in bracket you write a small l. Then this is the actually balanced equation. Balanced equation means 1 H2 plus half O2, it is forming 1 H2O. And this is not the only product. One more is there, which here in this chapter thermodynamics we are giving importance, that during this reaction how much heat is associated. Then here you must write, you will have to write that what is the value of delta H. Then here delta F means formation. Delta F is equal to means heat of formation. Then heat of formation here means the delta H value is minus 285.8 kilojoule per mole. Okay, means along with the water it will release 285.8 kilojoule per mole. Heat will evolve. That's why minus sign is written. Delta H is minus 285.8 kilojoule per mole. Why minus sign you are writing? Because during the reaction heat is coming out. This amount of heat is coming out. Then heat, if heat is coming out, then it is called exothermic reaction. When heat evolved, it's called exothermic reaction. And this amount of heat, they are decreasing from the reactants. From the reactants, they have lost this heat or energy, and it is coming out. Means in the formation of water from H2 and O2, 285.8 kilojoule per mole heat is going out. That is evolving, releasing. That's why it is an exothermic reaction. In every time in exothermic reaction, heat is evolved. It releases heat. Don't forget, always delta H will be negative in case of exothermic reaction. Okay, now another example I am telling you. Carbon means graphite. Graphite solid I am talking about. Carbon plus hydrogen gas. Carbon plus hydrogen gas. Then in bracket you write G. Then carbon and hydrogen gas, when both will react, what will it form? Then it will form methane gas, CH4. Okay, means carbon, graphite in solid plus hydrogen gas, it will form methane gas. Then you write for the carbon, graphite, it is a solid, then in bracket write a small s, a solid. And here balanced equation you should write. Then balanced equation you will write, then it will come C plus 2H2. 2H2, coefficient is 2. And because it is hydrogen gas, then you write G. Okay, just a small g you write near the H2. And finally it is forming CH4. Then after the arrow sign, you write CH4 and just gas near the CH4, you write G, a small g in bracket. Okay, then C plus 2H2, that is CH4 gas. This is the balanced equation. Then now here you have to give the importance. Here more important is to give the value of delta H. Delta H may be positive, delta H may be negative. Delta H negative means exothermic reaction. Heat will evolve. It will go outside. And delta H positive means it will absorb the heat during the reaction. You have to supply the heat. Heat it will be absorbed. In that case, delta H will be positive. Don't forget. This is the only difference you can do whether reaction is exothermic or endothermic. By seeing the sign, you can tell. If negative means exothermic, if positive means endothermic. Then in this reaction, carbon plus 2H2, it is forming CHO4, means 1 mole. 1 mole of carbon, 2 mole of H2, it is forming 1 mole of methane. Formation of 1 mole of methane. And in this reaction, minus 74.8 delta H value is minus 74.881 kilojoule per mole. Then here again we see value is in negative. It means it is exothermic reaction. Heat will come out, heat will evolve, or it will release heat. Okay, and delta H value is minus 74.81 kilojoule per mole. You have to write near the equation. This value you have to write. Then this is the heat of formation, delta F. Delta F value is minus 74.81 kilojoule per mole. Now here third example I am giving you. Third example. Again graphite plus hydrogen. See what I given example, that was also graphite plus hydrogen. Now again graphite plus hydrogen. Graphite is in solid state and hydrogen is in gaseous state. Plus here extra things you are adding oxygen. If three things are there, carbon plus hydrogen plus oxygen, three things, carbon solid, hydrogen gas means the small g you have to write, and half O2 means gas, correct? Then what will it form? Then carbon is there, hydrogen is there, oxygen is there. Then it will form ethyl alcohol, C2H5OH, liquid. This is the liquid. It will form liquid. And what will be the delta H value? Then delta H value will be again a negative. That is delta H value will be minus 277.7 kilojoule per mole. Because in this reaction only 1 mole ethyl alcohol is forming. 1 mole. Hence whatever value is there, always heat of formation is for 1 mole only. Okay. Only for 1 mole. And if it is forming 2 mole or 3 mole and value they have given, then you have to divide it by that coefficient. Suppose it is value is given for 3 mole, then you have to divide by 3. If value is given for the 2 mole, then you have to divide by 2. Means always you have to tell for this heat of formation for 1 mole only. Again 1 marks question. Okay, 1 marks question, sometimes 2 marks question also. Okay. Then here very important things I told you, but here balanced equation, what will be the balanced equation? Then 2 carbon is required. 2 carbon, 3 hydrogen. 2 carbon, 3 hydrogen and half oxygen. Half oxygen. Then it will form C2H5OH. C2H5OH, ethyl alcohol. And how much heat it will evolve? It will release. Then delta H is equal to minus 277.7 K. Means 277.7 kilojoule per mole heat will come out. Then 3 example I have given you. Now again one very interesting example given you. Generally a student will get confused and they will do wrong in examination. Now suppose calcium oxide, that is a solid actually, a small letter you can write, calcium oxide, CaO, there you write a small s in bracket, plus carbon dioxide, that is the gaseous form, G you can write in bracket. Then calcium oxide plus carbon dioxide, it forms calcium carbonate, CaCO3, calcium carbonate, means CaO 1 mole plus 1 mole CO2, and after arrow sign it is giving product CaCO3 1 mole, that is the solid calcium carbonate. Okay. Then this calcium carbonate 1 mole it is forming. Then delta H value is minus 178.3 kilojoule per mole. Minus 178.3 kilojoule per mole. Then easily you can tell value is delta H value is minus, then reaction is exothermic. Exothermic means heat is coming out. That's why that in Deepavali time, why this whitewashing you are doing in a home, then that is the stone is that is of calcium carbonate, and when you are putting inside the water, then it will evolve carbon dioxide. Okay, it will begin to boil water plus calcium carbonate, that is a stone of limestone, what you are telling limestone, then limestone plus water, In limestone, we will put water, it will dip it, then there will be effervescence. Gas will come out, bubbling will be there. That carbon dioxide will come. And if you will touch the water, their hand can burn because it is releasing heat. Then this is this heat. Delta H is equal to minus 178.3 kilojoule per mole. This heat is coming out. That's why that time you will feel warm. Then this is an exothermic reaction. But now a very important thing is that this reaction, okay, the enthalpy change for an exothermic reaction, I have told you calcium oxide plus carbon dioxide, it is giving calcium carbonate. Then this reaction is not an enthalpy of formation. 2 marks question. Okay, this reaction is not an enthalpy of formation. Heat is coming out. Then heat is coming out means not always it is always that it will be heat of formation. This is exception. Generally in 90% cases that will be heat of formation will be exothermic only. 90% cases. But no, exception is also there. Then this is an exception. Question will be asked. Okay. Then this is not the enthalpy of formation. Why? Again for IIT advanced. This question, all why question, it is for advanced level IIT. Then here, why it is not the enthalpy of formation? Heat is coming out. It should also be like others. Then no, it is not an enthalpy of formation of calcium carbonate. Answer, you understand why not. Then since calcium carbonate has been formed from other compounds and not from its constituent element, calcium oxide is not element, carbon dioxide is not element, means reference. It is not the reference state or a standard state. Calcium oxide is first, it is not an element and it is not elemental state also. Okay, already I told about the reference or standard state. It is calcium oxide, other is carbon dioxide. Then both are not, you can say, elemental state. They are not formed from other, this is not from its constituent element. Okay, it is forming from calcium oxide. It is forming from carbon dioxide, not the constituent element. That's why this is not an enthalpy of formation. Heat released, that is not an enthalpy of formation. Okay, this type of question is asked. Okay, for the formation, they must be from their elemental state or reference state. I told you maybe H2, maybe O2, maybe carbon graphite, maybe sulfur rhombic, like that way. Okay. Then this I have told you. Also for the reaction, again one more example I am telling you. Already I have told you, but again I am telling you with example. H2 plus Br2. H2 is the gas. H2 is gas. A small g you can write. Plus Br2. Bromine is the liquid. Br2. And it is forming 2HBr. Hydrogen bromide. 2HBr. HBr is gas. Okay. Hydrogen is gas plus bromine. Bromine is liquid. In bracket you can write L, small l. And after the arrow sign, you write twice HBr. Product is twice HBr, hydrogen bromide. That is the gas. And delta H value is given minus 72.8 kilojoule per mole. Minus 72.8 kilojoule per mole. That is the delta H value is minus 72. They have given. But here this is also not the you can say standard enthalpy of formation. Enthalpy change, this value is also not a standard enthalpy of formation. You will ask why? Why not? Heat is coming out, minus delta H is minus 72.8 kilojoule per mole, but it is also not the, you can say, enthalpy. This enthalpy change is not a standard enthalpy of formation. Why? Because I told you this is for 2 moles, 2 HBr, means 2 moles of HBr. Okay, then here you have to write for 1 mole, and this value 72.8 kilojoule you have to divide by 2, then it will be correct. Okay, means delta H value is for 2 mole HBr, hence you have to divide it by 2, then for 1 mole you will get. Therefore, by dividing all coefficients in the balanced equation by 2, means H2 plus Br2, that is equal to 2 HBr, then all coefficient of the balanced equation divide by 2, then it will give you 1 mole of HBr, means half H2, half Br2, then 2 HBr divided by 2. Here also 2 divide. Here both side, left hand side, right hand side, divide by 2. Then half H2 plus half Br2. Here 2 HBr was there, then again divide by 2. Then it will form 1 HBr. Then value will be for 1 mole. That is a 20. That is the 36.4 kilojoule per mole. Okay. This I have told you. This again question is asked. Whatever this very important for examination I am telling you, and this you should always keep in mind that only this type of reaction, if not the same, generally in IIT same things what I am telling, that direct question they are not asking, they are asking concept based question. Concept based, you can only in this university examination or board examination that they will ask a direct question. Okay, but in IIT or medical or any other competitive examination, they will ask a concept based question, means you have to think and then you have to answer. Then these things are this what I have discussed now, last two examples, that is the concept based. Okay, then I will point out always whenever this type of question I will get it. Okay, then I told you for this reaction 36.4 kilojoule per mole, that is the correct answer, and reasoning also I have told you. Okay, now again just another example I am telling you. Okay, that suppose reaction is going on calcium carbonate, and it is calcium carbonate on heating, it will give you calcium oxide plus carbon dioxide. Okay, suppose you want to know what is the delta H value. You don't know what is the delta H value. Then here how will you find this delta H value? This is actually experimental. I will come to that point also. Then how will you calculate this calcium carbonate on heating? It will give two products. First, calcium oxide, that is a solid, CaOS you can write in bracket, a small bracket, and carbon dioxide, CO2 gas. What I have told you now just before this, that this limestone, when you put in water, then effervescence comes, means carbon dioxide comes out, and heat also it produces. But what product it forms? Then you might have seen that one lime will also it formed. Okay, that is calcium oxide. Beetle, beetle you are eating, green leaf, beetle. That time this only calcium oxide, white color in a small quantity is used, calcium oxide. Okay. Then here calcium carbonate, here on decomposition, after heating it will decompose and it will provide you calcium oxide plus carbon dioxide. Then how much heat it will evolve? How will you calculate? That question is also asked. Then here to calculate these things, one formula is there. Last class I have already discussed. Then delta H is equal to you can say sign of summation sign, sigma sign. Then sigma sign you write, and heat of formation of products minus summation sign again, heat of product of reactants. This is the formula. Product minus reactant. Product minus heat of formation of products, maybe 2-3 products, minus again summation sign, sigma sign, heat of formation of reactants. Okay, heat of products, maybe 3 products or 2 products. Then you can write coefficient. If it is 2, then you write 2. If it is 3, then you write 3. Okay. Before heat of formation you write 3. You have to multiply by 3 or by 2 according to the this how many products are there. Like that way, it's this reactant side also you are doing minus. Then there also how many reactants are there? As for example, here only 1 reactants are there, calcium carbonate. Then you multiply only by 1. In the beginning only write only 1 into H value. Then this is the important formula I have told you. Okay. Then now some example I am giving you. Okay. Only this calcium oxide is after heating, after decomposition, it gives calcium oxide plus carbon dioxide. Okay. Only this value I am giving you, and you don't know what is the delta H value. Now we will come to know. Then here in this formula, what I told you, product minus reactant, delta H is equal to for heat of formation of product minus heat of formation of reactants. Then now it is very easy to get the result. Actually in examination they will give the value of heat of formation of product and they will give the value of heat of formation of reactants. They will give. Then what is the problem? Only you put the value, get the result. Then here delta H is equal to, for calcium oxide solid, they will give the value. As for example, its value is minus 635.1 kilojoule per mole. Okay. Then this value you are knowing. Then 2 products are there. It is calcium carbonate. After decomposition, it is giving 2 products, calcium oxide plus carbon dioxide. Then product value you first write. Then calcium oxide value is minus 635.1 kilojoule per mole. And for carbon dioxide value is only 1 mole is there. Then only 1 you have to multiply by only 1. And this also calcium oxide was only 1 mole. Hence again you multiply by only 1. Means product side you have to multiply only by 1. For calcium oxide also 1 into calcium oxide, carbon dioxide 1 into CO2. Then now for carbon dioxide value is given minus 393.5 kilojoule per mole. Okay. Then these 2 value for the product you have written the value. Correct. Then after that what we will do? Minus reactant side. Then reactant side only calcium carbonate is there. Then minus for calcium carbonate, heat of formation is value is given 1206.9 kilojoule per mole. 1206.9 kilojoule per mole. And calcium carbonate is only 1 mole. hence you multiply by only 1. Then you have put the value. Then now only you solve it. Okay, just you after putting the value solve it. Then you will get final value you will get after doing solution. After solving it, you will get 1 plus 178.3 kilojoule per mole you will get plus. Then what you will conclude? Then okay, this reaction is a plus, delta H is a plus, delta H value is plus 178.3 kilojoule per mole. It means it is endothermic reaction. It is endothermic reaction. Then like that way numericals will be asked. Then an example I have given you. Like that way in the place of calcium carbonate they can give other things. But you will solve accordingly. First value of heat of formation value for products you write. Add all products value. After that minus. Again minus you write the all values of the reactant and add it. And finally minus sign is there in the middle. Deducted. You will get the value of heat of formation. Here I want to tell you, heat of formation, many reactions are there. Then sometimes formation, you are considering formation, then you will use the term heat of formation because heat is involved. Sometimes combustion is going on, burning is going on. Combustion means burning. That time again heat is involved. Then that time you will tell heat of combustion means enthalpy of combustion. Like that way many reactions are there, different type of reactions are there, then different type of enthalpy will be there. Enthalpy change will be of different type. Don't think is very seriously that types of according the types of reaction enthalpy change will be there. Then here in general way, when many types of reactions are there, then you should tell in one way, in a simple way, in general way, how will we tell? Then you will tell by heat of reaction. Heat of reaction, a small r, delta and a small r you can write. Then in a general way, heat of reaction. But what type of reaction? Then if you are considering particular reaction, then you have to use the term for heat of formation, for heat of combustion, for heat of fusion, for heat of heat means enthalpy of formation, enthalpy of sublimation, enthalpy of fusion. Like that way you can give the term. Okay, 2 to 3 letter only it is written. For the sublimation ACUB, for the combustion COM. Like that way it is written. Then delta R means in general way you are writing delta R. H means heat of reaction. Just like you are telling food is ready. Then person will ask what type of food is there. Food may be of different type. Same things are there. Heat of reaction is a general R. But in that what type of reaction is there? Then you have to come to particular. Okay. Then I have discussed about these things. Heat of formation or enthalpy change of formation. Today I am stopping only here. Next class I will continue with other terms. Many terms are there. Then I will discuss other terms. Okay, next class. Thank you.